Okay, this is the fifth and final problem in the tutorial on logarithms using logarithms to solve problems with pH. This fifth and final problem is the reverse of the previous two. It says if a fluid has a hydronium ion concentration of 2.5 times 10 to the minus 6 moles per liter, then what's the pH? In this case, we're going to work with this expression. We're given a hydronium ion concentration, and the task objective is to compute the pH from it. So the hydronium ion concentration is 10 raised to the power of the negative pH. We have the hydronium ion concentration, so the log of the hydronium ion concentration is equal to the log of 10 to the minus pH, which is minus pH. This is an application of that fourth property of logarithms, which says the base 10 logarithm of 10 raised to some exponential power is that exponent. So to get from this step to this step, we just took the logarithm of both sides. So the logarithm base 10 of the hydronium ion concentration is equal to the logarithm base 10 of 10 to the power of the negative pH, which is equal to the negative pH. Next, multiply both sides of the expression by -1 so that pH becomes a positive value and the logarithm of the hydronium ion concentration becomes a negative number. Now the logarithm of the hydronium ion concentration is the logarithm of 2.5 times 10 to the minus 6. That's a product. And the logarithm of a product is the sum of the logs. So the logarithm of 2.5 times 10 to the minus 6 is the logarithm of 2.5 plus the logarithm of 10 to the minus 6. And remember, all of this is wrapped in parens with a minus sign in front of it because pH is the negative base 10 logarithm of the hydronium ion concentration. So we're trying to compute the negative of the log of 2.5 plus the log of 10 to the minus 6 power. And the easy part of this is the base 10 logarithm of 10 to the minus 6 is -6. The harder part of this expression is the logarithm of 2.5, and you'll need a calculator or a math program to solve that. But the log of 2.5 is 0.3979, and base 10 log of 10 to the minus 6, which is -6. So pH is -1 times 0.3979 minus 6, which is -5.6. The opposite of -5.6 is +5.6. So using this expression, we're given a hydronium ion concentration, and we can determine the pH from that. So if the hydronium ion concentration in a fluid is 2.5 times 10 to the minus 6 moles per liter, that's equivalent to a pH of +5.6. Again, notice that the ion concentration and the pH are both positive values. This concludes the section of the tutorial on logarithms using logarithms to solve math problems with pH. And the problems that you see will either consist of you're given a pH and asked to compute the hydronium ion concentration, or you'll be given a hydronium ion concentration and asked to compute a pH value. Keep in mind the product rule of logarithms, which says the log of a product is the sum of the logs, and the base 10 logarithm of 10 raised to some power is that value. Those are the two relevant rules and properties in logarithms that are important to remember, keep in mind, and understand when solving math problems with logarithms. The next and final section deals with logarithms and interest rates. I hope this is helpful and informative, and if you have comments or questions, please post them to the comments section of this video in YouTube, and I will respond. Thank you for watching.